My name is Henrik Nolan. I'm the CEO of renewcell, which is a Swedish company based in Stockholm. We've been around since 2012, and we were formed by a group of pulp chemists who realized that they were pretty good at recycling paper, and they could probably do the same thing with cellulosic textiles. So since 2012, we've been working on this and have come quite a long way today. Really, there are two problems we're trying to solve, and they both relate to the fact that our planet is a bit too small. First of all, textile demand is increasing for every year that goes, and the textile industry is finding it harder and harder to find fibers to meet this demand. So we thought, instead of producing new virgin fibers all the time, couldn't we just take old used fibers and give them a bit of a polishing and reintroduce them back into the textile production chain? So that's one of the reasons for what we're doing. The other is, of course, the environmental footprint. That for every ton of fiber we are using today, we're creating quite large environmental problems, and that needs to be solved. And one of the ways of solving that is by recycling the fibers. Everybody working at renewcell has really a background from the pulp business or the wood pulp business, and we got a question if we could recycle textiles in the same way we were producing pulp, because textiles or cellulosic textiles are quite similar to cotton. So we started looking at that and we realized, yeah, well, it's not going to be easy, but there's a chance we could do this. So we gave it a go, and so far we had really, really good results. All textiles based on cellulose, so that's cotton and man-made cellulosic textiles, which is like viscose or lyocell, and then there are a couple of smaller trademark fibers which are also made from cellulose. What we do is we take used textile waste, and we shred it first, so we get small fragments of textiles. Then we put it through first of many processes, which is a de-dyeing, de-finishing step, where you take textiles of many colors and many types, and you try to make them a bit more homogenic. So in the end, we get a white kind of slurry. Now, from this slurry, we need to adjust the properties of the textiles to really go from being textiles to actually being dissolving pulp, which is what our customers need to produce new textiles. And this is really where we have lots of unique solutions of really adjusting properties to make sure it ends up just right. And in the end, what we do is we need to get rid of anything that's not cellulose from our slurry. So we have a step where we get rid of zippers and oil-based fibers and other contaminants which shouldn't end up in the end product. And the last step is, of course, drying the slurry to what looks like paper pulp, which can be sold to textile fiber spinners. Well, there's a couple of things that are really unique with what we've managed to do so far, and that's, first of all, we're taking used, unwanted textiles, and we're actually creating fibers of very high quality. We even surprised ourselves by the quality we reached. The second uniqueness is that it's cheap. We'll be able to sell recycled fibers at the same price as new fibers or virgin fibers, which also is really unique. So these two things, good quality and good price, is something that really makes us confident that this will make a good impact. 2030, I think we'll be seeing a totally different apparel industry. I think the road going there will be one of many phases. I think we'll be seeing development into more both long fashion, where you produce apparel of very high quality, which will last pretty much forever, but also some very, very fast fashion. But this fast fashion will be designed for recycling. It's quite natural to think that anything that is made to withstand the test of time will also be harder to recycle. So that's kind of the in-between scenario. In the long term, I think by 2030 we'll be seeing technologies which are really good at separating mixed fibers, which is kind of a holy grail of textile recycling. I think that will happen by 2030, and then you'll have some technologies taking care of the cellulosic part of the fibers of the textiles, and some technologies taking care of the oil-based fibers. So you'll be seeing a mix of technologies, and by then I think designing for recycling will be a natural part of the design phase. So by that time, the two will meet, so to say. Renewcell will be one part of a spectrum of processes which will take us from the non-looped textile industry to a looped textile industry, and I look forward to taking part in that.